There's a few different kinds of blocks in TIA portal. OB, organization blocks, FC, functions, FB, function blocks, DB, data blocks, IDB, instance data blocks. And each of them is different, each of them has their own purpose, and it can get a bit confusing in the beginning if you don't know how to use them yet. I will show you what all of them are and what's their purpose. I will also show you how I use them in my programs so you can understand how you can use them in your programs.
Okay, so this time I wanted to start from the other side. So I've started to write the code for the project already, and to show you how I'm using the certain types of blocks in the program, I will just show you how it looks like in my program. Let's start with a bit theory about OBs. I told you a bit about them before, but just a quick reminder. So we have different kinds of OBs in TIA portal, and they are called in different circumstances. So the main OB, the one that I am using the most, is OB1. So this is the one where inputs are read. After that, OB1 comes, so the program from OB1 is executed. Then there are self-diagnostic functions proceeded, and then after that, the outputs from the PLC are written. And I'm using this the most. Some customers require using different OBs, for example, motion control. And I know some people do that, and they use cyclic interrupts for that, so that they are sure that the code is executed every 50 milliseconds or whatever they said there. This one, I also use it quite a bit, especially for communication purposes. And startup will be the one that is called only on the startup of the PLC. Well, there are many different kinds. The thing to remember about the organization blocks is that they are a starting point for executing the code. Let's go to my OB1 and what's in my OB1. I call two functions here, FCs. In this case, I'm using specifically FCs here, and I use FCs in two different ways, because FC is a function, so it can get inputs, process the inputs, and then spit it out as the outputs. So I used one of the blocks from the library I'm writing at the moment. This block is taking byte as an input, and it's processing it, and it's just spitting out all the bits from this byte. So I use the clock byte here. It just separates all bits from this byte. In this case, it's a clock byte. I wouldn't have to do that, but if there is some byte coming from some gateway, for example, from a different PLC or from the HMI, I sometimes have to take the byte in and have bits as an output. So I will go online so you can see what it's doing. It's just taking this byte, and these outputs are blinking with different frequencies because it's a clock byte that you already know from the previous videos. The other way I'm using FCs, I'm using functions to kind of organize my program. I organize stuff in the project tree by creating some folders here, but I also organize the program inside. I organize the call structure. I created these FC sensors. As you see, it has no inputs, no outputs. It doesn't need them because what's inside, I'm only calling some blocks here. What the blocks are, I'm going to explain you in a second. So this is FC. It's processing some code without using a memory dedicated for this FC. So this is just a function. Now, what's inside of this FB? Maybe let's go back a little bit. So I started to work on a new project for this tutorial and for the course that I'm working on, and I'm using the existing scene and it's going to be sorting by height, the basic version of it. So what I've seen here is that we have many sensors, many light barriers. And the thing about sensors like this is that we use them usually more than in just one place in the program. And also we often need like rising edge, so we need to know exactly when something appeared on this sensor, or falling edge, so when something disappeared from this sensor. Also in real industrial environment, it's very often that there is some flickering on this sensor from some kind of dust, or suddenly it should detect something but the signal disappears. It just happens. So I decided to create a block which is going to be one of the blocks in my library that I'm going to use also in my future projects. And this block is going to take the input from the sensor, process it, and just spit out the output, so that I can store this output somewhere in the DB, of course, but I will get to that in a second. And then I'm not looking at this physical input anymore. I'm just looking at the processed values, because they will be much more useful for me. So I decided to create a block that will process an input from a sensor like this, and then I'm going to use this block for every sensor I have in this application. So we have 1, 2, 3, 4, 5, 6, 7, and 8 sensors like this in this project. So for every sensor, I'm going to call this block. But I've written this block and I'm using an FB. So FB is like a function, but with the memory. So to process some whatever FB has to process, it needs some memory. So that's why we're going to use an FB. So inside of FB, we have this static memory here. And this is the difference between FB and FC. FC doesn't have static memory here, FB has it. And this static memory is going to be stored somewhere. I will tell you where in a second. So anyway, these values will be remembered in the next cycle of the PLC. I'm calling this FB from FC. How I do it, I just pick this block from here. I put it here, and it wants me to create a DB for that. In particular, this type of DB is an instance DB. What does instance DB means? It wants to reserve the place in the memory of the PLC, but it wants to reserve it in a very specific way. Now look at this. This is the interface of this FB, lib binary sensor. And now I'm calling this FB from FC called sensors. We've got the name here. And I'm creating this IDB. And if you look what this instance DB have inside, it's exactly the same thing as the structure of this function block interface. It's going to store the values from the interface of this FB. So this is the instance DB. The instance DB is the memory that is reserved in the memory of the PLC to keep whatever the function block needs. And the last thing is DB, so data blocks. I create a separate folder for them, usually in the project tree. They are global memory. So usually I don't even look to the instance DBs unless I'm troubleshooting somewhere I have some real trouble. Then sometimes I have to look into instance DBs. But normally all the values that are accessed inside of the program are stored inside of the global DBs, so normal DBs, so to say. So instance DBs are only FB calls, and global DBs. In global DBs, we are writing to them and reading tag values. This is the basic difference. Once we create instance DBs, we don't usually look to them. With the FBs, we are writing and reading values. And this is actually exactly how I'm doing here. I'm taking the outputs from the FB and I'm writing them straight to the global data block that is called sensors DB in this case. Now, let me show you how I got here and why I did it. So the first thing I want to do, I want to create a place where I will process all the inputs. I could process them in OB1. In fact, it is possible to read your entire code in OB1. But imagine you want to process 8 inputs, only 8 inputs in OB1. It makes 8 networks, and you haven't even started to write the control for the machine. It's just processing inputs. So I'm going to create a place where I'm going to keep this code for the inputs, and I'm just going to call it from OB1 so that it's going to be processed, that I will be sure that it will be processed. I'm creating a new block, and this is going to be an FC, of course. And the first thing that I'm doing, I'm just placing it in OB1, so I don't have to remember about doing that anymore. From this OB, from this FC, I want to call all the FBs. I want to process all the inputs here. But to process each input, I need the same piece of code repeated many times for each of the sensors. So I'm just going to use an FB as this repeatable piece of code. Let's go offline. What I'm going to do, I'm going to create a block, and I already know that I'm going to use this block a lot in the future, so I'm just creating it as a library block. I know that I'm going to take this piece and use it many of my programs. So I'm just creating a new block here, and I know it's going to be an FB, and I'm going to call it lib, which stands for library in my nomenclature, and then binary sensor. I like this name, so I'm going to use this one. And what kind of inputs am I going to need? So I know I'm going to need the input from the sensor, obviously. Sensor in. Okay, what else am I going to need? I know I'm going to filter the signal. There's a way to filter a signal with very simple way with on delay timers and off delay timers. I'm going to show it in a few minutes how it works. Anyway, I know I'm going to need this as a parameter, because sometimes you need a stronger filter, sometimes you need a weaker filter. So I want to have it as a parameter here. So on filter delay and off filter delay, and they're both going to be of the time data type. I want to talk some more about data types, and I'm going to do it in my course, but I think I'm going to release this video also free on YouTube, because I think it's it's a very important topic. Everyone needs this knowledge. So the outputs. First thing I want to do, sometimes in the code I might need the copied unfiltered signal. It's not very often, but sometimes it can be necessary, so I will just pass it outside too. This is the first one. Of course, I will need a filtered signal. So this is another thing I need. I also need the positive edge and negative edge. This is the inputs and outputs I will work with. I'm sure I will need some static variables here, but we'll get there while I'm coding. because I'm not going to predict all of them probably anyway. First thing I do, I'm going to make to pass the copied signal. This is the simplest thing. So sensor in goes here. One output already handled. Okay, now the signal filtering. Okay, so we need an on delay timer and off delay timer. Why on delay timer? So sometimes it happens that there is some, I don't know, dust in the air or anything that makes the sensor react even though it shouldn't react. So we want to filter out this kind of situations. So that's why we're going to use the on delay timer. So timer operations, you know this already from one of the previous videos. TON delay filter, and you see that we have different choices here. We can pick single instance, which will create an instance DB, multi-instance, which will cause the DB that we need for this timer to be included inside of the instance DB that will be for the entire function block that I'm working on right now. I will show it to you in a second when I finish this block, and when I make the call, you will see what's there in the instance DB for this binary sensor block. So I will choose the multi-instance, and there's also the third option, parameter instance. To be honest, I haven't used it yet, but well, you can use it. Swap the instance DB in the program during operation of the PLC. So for example, if you have loops, okay, if you have loops where you are calling the same FB but for different devices, for example, you can use this parameter instance DB. It's a bit higher level programming. It's a bit more difficult stuff. I don't want to do it here because I just want to show you the simple stuff first. So let's just stick to simple stuff. And what do we have here? Of course, TON. You know how to work with it already. I'm just passing the sensor in signal, and we already have this input prepared. So we're going to use on filter delay, and now the off filter. Why do we need off filter? Well, sometimes for various reasons, the signal might disappear even if it doesn't need to disappear. So suddenly we start to detect something, even if we should detect it, and then detecting is back. And we want to avoid this kind of situation. We want to also filter it out. So that's why we're using off delay filter. So TOF. And now we have the filtered signal, but we're going to need the filtered signal also for detecting the edges. So I'm just going to use a temporary variable here. So I'm going to sensor filtered, use this guy in this place, and now and edges detection. It's going to also be very simple. You already know how to deal with positive and negative edges. So I'm just going to Of course, we're going to need some auxiliary variables to remember the state of the previous sensor filter value. It seems like the code is almost finished. I still have to test it, of course, because everything that you do, even if you're sure that it's going to work, you have to test it. Until you've tested it, you're not sure if it's going to work. So I have to test it. One more thing that I would always do, I'm not going to do it right now though, is I'm writing the comments for all the inputs and all the outputs. And sometimes also for some of these static variables. I'm not going to do it this time, of course, because they're obvious. The code is very self-explanatory, but normally I do that. So now let's use this block that I've just written. What I'm going to do, I'm just drag and dropping it here. And now I have to create the first instance. So the first instance will be for the first sensor. I've got it. And the first sensor is pallet sensor. So I'm going to use this one. So I will call it pallet sensor IDB. I like to clarify that it's an IDB in the name, and of course I'm moving it to the IDBs folder in the project tree. Sensor in, of course it's going to be the pallet sensor IDB, and I'm going to make 50 milliseconds. Actually, for testing it, I will change it to like 2 seconds to see if it's actually working like it should work. And now the outputs. So I want to write the outputs into a global DB so I can reach to these values afterwards. So I want to create a global DB. I'm adding a new block and I'm choosing data block and I'm calling it sensors DB. Okay, so it's clear what this DB is for. So what I want to do, I want to create the tag for every output I've got here, and the best way to do that would be to create a structure for each sensor here. But I don't want to make it too confusing for you right now. I will just mention that I will make a video about structures and also PLC data types, which are very useful thing to organize the memory inside of your PLC. I will release it as a free video. It will be part of the course, but I will release it as a free video because I think it's very important for everyone to know it. What is going to be there? I'm going to call it the pallet sensor CPY. I don't want them accessible and readable from the HMI. I don't need that at the moment. And what I'm going to do, I'm just going to drag and drop it from here to here as always. This is so easy in TIA portal. It's so much better than step 7 was, for example. Maybe more convenient. Better is not the best word because some people would be so angry if they hear that TIA portal is better than step 7. Anyway, I like TIA portal much more than step 7. This is for the pallet sensor. And we have to create such block for each sensor that we've got here. It seems like it's a very painful process and it's really slow, but it's really not, because even if you have, say, 50 or 100 sensors like this in your project, you only have to do it once. You do it once and then you can use these signals across your program. And if it's a big project, you can spend an hour or two on that, but it's going to make your life so much easier in the future. So how I like to think about writing a program for PLC is I like to kind of divide it to smaller parts, because if you look at it globally, it's so complex. But if you look at the details and you're able to divide your program into smaller pieces, they become simpler, okay? And they're just like Lego pieces that are there together and they're kind of interacting with each other, but each of the pieces is relatively simple. That's how I like to write my programs, and that's also how I want to teach you to write your programs in this course. I'm going to do this project and probably 2 more projects so that you get a good understanding about how you can divide these complex problems into smaller problems that are easy to solve. Anyway, back to this. We've got one sensor already handled here. And let's pick another sensor, so the low sensor. So I'm just going to do exactly the same thing. So lib binary sensor, IDB, and I'm going to do the same thing here. So I'm going to connect the input low sensor, set the time for on delay filter for 50 milliseconds, T sharp 50 milliseconds, same here. And on the output, I will also connect the tags from the DB. So what I'm going to do, I'm going to copy paste it, and I'm going to use a replace function. So what I'm going to do, I'm going to type palette and change it to low. Okay, find, replace, 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 replace. Okay, and also whenever there is 1, I'm going to replace it with nothing. Okay, that was very simple and very quick. I'm actually using this function a lot here, and it can really speed up writing the programs, especially if you have repeatable parts of code and you just need to change one detail and it's the same detail everywhere. So that's also why it's really good to be kind of consistent about the way you're naming your tags in your code. So this is called the low sensor, and there is 6 more sensors. I'm not going to do it now. Anyway, I told you that I'm going to show you what's inside of IDB. I told you that I'm going to use the multi-instance DB, and that's exactly what I did for the timers here. Okay, what did it cost? Because I used multi-instance DB, it didn't create a separate instance DB. It puts the memory for these timers inside of instance DB for the sensor block. So I don't have to create a new DB for everything that needs an instance DB inside of NFB. I can just put them inside of the DB for the master FB, so to say. So for the FB that is higher in the hierarchy. That's very convenient, and that's why I also like using FBs so much, because they make this so much more compact than FCs. If this FC wasn't FC, if it was an FB, we could also do the same thing, just one level higher. But anyway, this is how I'm using FBs, FCs, OBs, DBs, and IDBs. I hope you have a better idea about how to use them. And I think that's it for this video. If you are interested in learning some more, in learning how to make your coding simpler and also easier to read for a person who's going to maintain your code, then I invite you to check out my course. Even if you're not interested in the course, you can go to the website, leave your email, and you'll get notified whenever I release some videos about tricks that I'm using when I'm programming in TI portal. The link to this website is in the description. And also, I invite you to join our Facebook group, where you can ask other people who are also learning to program in TI portal questions about some issues that you're encountering during learning. And I will also try to answer as many questions as I can. And I hope you will see me in some of the videos in the future.